Hi, welcome to the lecture number one for your topic waves. This is the third topic, subtopic wave behavior. In this topic, you're going to learn about refraction, reflection, and there's one more thing which is known as diffraction. Okay, we know that all waves, whether it is transverse wave or longitudinal wave, they all can be refracted, they all can be reflected, and they all can be diffracted. All right. So when we talk about reflection, what is reflection? Obviously, you might have heard the terms when they say, "Oh, the mirror is reflecting your picture." Okay, reflection basically occurs when we're talking specifically about in the waves. Where does reflection take place in waves? So talking about waves, reflection occurs when a wave hits a boundary between two media and does not pass through, but instead stays in the original medium. Okay, this is what is meant by reflection. It says a wave hits a boundary. Reflection occurs when a wave hits a boundary between two media and does not pass through, but instead it stays in the original medium. If you have studied about the reflection earlier, you also know that there is a law of reflection. There is a law of reflection. Okay, the law of reflection says that the angle of incidence is equal to the angle of incidence is equal to the angle of reflection. Since we're talking about reflection, it says the law of reflection says that the angle of incidence is equal to the angle of reflection. I'll show you how it is being. What is the angle of reflection? What is the angle of incidence? If you can see this picture here, when they hit an object such as a barrier, let's say this thing is a barrier. Yeah, this is a barrier. So when the waves hit a barrier, they're being reflected. So here, the I here stands for the angle of incidence. This is the incidence angle, and this is the reflected angle, which is represented by an R. So the meaning, the law of reflection says that the angle of incidence is equal to the angle of reflection. So let's say, for example, if this is 40 degrees, this should also be 40 degrees. If this is 50 degrees, then this should also be 50 degrees. Why? Because the both should be equal. Okay. Now, moving forward, the next thing which we are going to talk about is refraction. What is refraction? Okay. Now, we'll write this down in bullet points. What is refraction? When waves enter a different medium, their speed can change. That's true. I'll write it down. When waves enter a different medium, their speed can change, which is really obvious. Their speed can change. Let's say different mediums. Obviously, you can say, let's talk about three different mediums. Water is one of the mediums. Let's say air is one of the mediums. A denser medium, you can say oil is a really dense medium. Okay, this effect is called refraction. And refraction, when does it occurs? We'll write it down also. A wave passes a boundary between two different transparent media, and undergoes a change in speed, two different transparent media, different transparent media. All right, now, so when a wave refracts, okay, there is a change in speed also, we discussed also, but alongside a change in speed there is a change in the wavelength. There is a change in the wavelength. All right, and one more thing will change, that is a change in the direction. So let's summarize refraction. Refraction is when waves enter a different medium, their speed can change. This process is known as refraction. How does refraction occurs? Is because a wave passes a boundary between two different transparent media and it undergoes a change in speed. Now, if a wave is refracting, we're talking about refraction. If a wave is refracting, then there's a change in speed already, but alongside a change in speed there is a change in the wavelength and there is a change in the direction. I will show you how it looks like. If you can see this diagram, this is water, this is one medium, and air is another medium. Okay, water is one medium and air is another medium. They both are transparent medium. This is the incident ray. And then when it's going into a different medium, it's going from the water to the air. So when it hits the air medium, it starts to get refracted. So the incident ray hits when the incident ray goes through the water medium to the air medium, it gets refracted, and you can see it's getting refracted in a different direction. So this is the wavelength of the incident ray and this is the wavelength of the refracted ray. So do you think both the points here are being matched? A change in the wavelength, yes, this incident ray is small and the refracted ray is big, so there's a change in the wavelength. There's a change in the direction, obviously there's a change in the direction. The incident ray is going straight, but the refracted ray is a bit tilted. All right, so waves change directions when moving between, this is a really important point. Waves can change direction when moving between materials with different densities. Okay, this is a really important point. I'm highlighting it like this so you can have a look, but do not write these notes right now. I will compile all the notes and send it to you. Listen, the thing is, when you write the notes, yes, you will automatically remember all this, recall all this stuff when we are solving questions. Past paper practice is really important. So when we are solving past paper questions, you will automatically recall that, oh yes, I wrote this down. So writing it down makes it easier for you to learn, understand and memorize as well. So let's talk about a point which says, if the waves slow down, let's say if the waves slow down, okay, so the wavelength will decrease. What happened to the wavelength? It will decrease. Okay, so the waves will start to turn slightly towards the normal, Now, what is the normal? What is the normal? This line between the two mediums is known as the normal, or you can say this line is known as normal. Let's ignore this line. Don't call this line as normal because this is between the two mediums. When any ray of when any incident ray, or when the refracted ray, reflected ray, diffracted ray, there's a line between them. It is an imaginary line which is known as the normal, okay. So this was one point which says if the waves were slowing down, obviously the wavelength will decrease. So what will happen to the refracted ray? It will move slightly towards the normal. Now let's say if the waves were speeding up, what would happen to the wavelength? What would happen? Completely opposite. The wavelength would increase. Okay. So will it move towards the normal, or will it move away from the normal? Like I said, it will occur completely in the opposite way. So it will move slightly away from the normal. So you can see slightly away from the normal. See, this is being away from the normal. Okay, so if it was being close to the normal, the line would go somewhat like this. Because it is close to the normal. Here it is far away from the normal, which means the wavelength is also increasing, and it is speeding up. Okay, talking about the last thing, which is known as diffraction. What is diffraction? Diffraction has a really simple definition. When waves pass through a narrow gap, the waves spread out. Okay, it has a really simple definition. When waves pass through a narrow gap, the waves spread out. This is known as diffraction. I'll show you how the diagram of a diffraction looks like. If you can see this diagram here, this picture shows the diffraction taking place. This is the narrow gap. Okay, and these are the waves passing through the narrow gap, and then they are being spread out. Okay, they are being spread out. Okay, there are some factors which affect diffraction. What are those factors? Let's talk about it. Diffraction only generally happens when the gap is smaller than the wavelength of the wave. If this narrow gap gets bigger, the effect gradually gets less pronounced. In that case, the gap is very much larger than the wavelength, so the waves will no longer spread out. If this narrow gap is larger, then the waves will not spread out. Listen to my point again. If the narrow gap is more larger, then the waves will not spread out. Okay, this is one of the factors. If you want, I will write it down. As the gap gets bigger, then the wavelength, the waves will no longer spread out. Sorry for my handwriting, I'm writing it a bit too fast. Okay, now How will this take place? Here is the picture. If you see here the wavelength and the gap size, the wavelength here is larger than the gap size. Here you can see the wavelength, the gap size is larger, and you see the wavelength is short. The gap size is larger and the wavelength is short. Here the wavelength is huge, the wavelength is spreading out, it is huge, and the gap size is small. So narrow gap, the wavelength will spread out. Okay, narrow gap, the wavelength will spread out. Here more gap, the wave will not spread out, it will go straight. You can see in both these directions. Here it is spreading out, and here no spread out. Why there is no spread out? Because the gap is larger. Why is there a spread out? Because the gap is small. And this, you see this curved lines, like these lines are like semicircle, so these lines are known as spread out. This is the spreading out of waves. This basically is an example of diffraction. As we looked here. Yeah. Now diffraction can also occur when the waves pass an edge. They can also occur when the waves, they pass through an edge. Now there's a very small example of it I can show you here. Okay, see, when they're passing through an edge, if you see, this is the wavelength and it's diffracted from this small edge, so they will curve. Can you see here? Here it is curving like this. All right. So when a wave goes past the edge of a barrier, this is the barrier, it goes past the edge of the barrier, the waves can curve around the edge. I'll write this very, very important point down. When a wave goes past the edge of a barrier, the waves can curve around the edge. Okay, so this sums up our topic, wave behavior, and the next lecture will be about the next topic, which is ripple tank. Thank you.